completing the square allows us to convert a quadratic from standard form to vertex form, which makes it much easier to graph and see the vertex, which remember is our h and our k, also known as our maximum or minimum. So if you have a quadratic binomial, quadratic meaning an exponent of 2, binomial meaning 2 terms, you'll be creating your C value. So when we look at our first example, we have a quadratic binomial. I want to put or create the form of ax squared plus bx plus c, but you'll notice that we don't have a c right now. We have x squared, we have x, but we don't have c. So we're going to create a space for it. We're going to move down to step 3, which now says we're going to divide our b term by 2 and square it. So if I'm going to divide my b term by 2 and square it, we're going to end up with, well, 8 divided by 2 is 4. And 4 squared is 16. But because we added a 16 out of nowhere, we created this 16, we have to also add it to the other side of the equation. This balances our equation. If we add a 16 over here, we also have to add a 16 over here. In step 5, it says factor the perfect square trinomial. This is a perfect square trinomial, which brings us back to our earlier notes in Unit 2. This means that we could write this as x plus 4, x plus 4. And because we have 2 of the exact same terms, we can now write it as an exponent, which is what we are trying to get to, because to write something in vertex form, we want to have an exponential value. We're then also going to subtract 16 on both sides, and this leaves us with x plus 4 quantity squared minus 16. Remember, vertex form is f of x equals a x minus h quantity squared plus k. So right now, we have that same format. We went from standard form, ax squared plus bx plus c, to vertex form, which is a x minus h quantity squared plus k, so that now we can see our h and our k. I know that our h and k are going to be negative 4, because we always think of the opposite, and negative 16. So this is also going to be the vertex. So now if I went to graph this, it would be much easier to do so. In our second example, it's slightly different. We're going to skip down to step 2, which says if you have a quadratic trinomial, so quadratic means exponent of 2, trinomial means 3 terms, you'll be moving your current c value, in this case our c value is 15, to the other side of the equation using inverse operations. This means that plus and minus are inverses, and division and multiplication are inverses. So because this is a plus 15, the opposite of plus is minus. So I'm going to subtract 15 to both sides first, leaving me with x squared plus 8x plus blank equals negative 15. Now we're going to leave this blank because this is where we're going to be completing our square. This step is exactly the same as what we did above. We're going to take our b value, which is in step 3. We're going to divide it by 2 and then square that. So 8 divided by 2 squared. X squared plus 8x plus 4 squared. 4 squared is the same as 16. But if we add b squared to the c location, which is what we just did, we also have to add it to the other side of the equation. So because I added a 16 here, I have to balance my equation by adding another 16 here. Our perfect square trinomial, which is step 5, is going to be x plus 4 equals 1. Negative 15 plus 16 is 1. This can be rewritten as x plus 4 quantity squared equals 1. And then if we subtract the 1 to both sides, we're going to have our quadratic in vertex form. So we started in standard form up at the top, ax squared plus bx plus c, and then by completing the square through all of these steps, we've now put it in vertex form, where we can see our h and our k. Once again, our h is negative 4, always think of the opposite. Our k is negative 1, which means this would be the vertex of our parabola. A rough sketch of that would be left 4, down 1, so it would look something along these lines.